Floating in the vastness of space, Saturn stands out as one of the most visually stunning planets in our solar system. Its iconic rings shimmer like a giant cosmic jewel, captivating astronomers and stargazers alike. But what exactly makes Saturn so famous? The answer lies in its breathtaking rings, which have fascinated humanity for centuries. As we begin our journey, let's explore the beauty and mystery that surrounds Saturn and its rings, setting the stage for a deeper dive into their secrets. Saturn's rings aren't solid structures. Instead, they are made up of billions of tiny particles, mostly composed of ice with some rock and dust mixed in. These particles range in size from minuscule grains to massive chunks as large as mountains. The icy particles reflect sunlight, giving the rings their brilliant appearance. This unique composition is what makes Saturn's rings so bright and visible from Earth, unlike the rings of other planets. Understanding the makeup of these rings helps us appreciate their beauty and complexity. When we talk about Saturn's rings, their size is truly astonishing. The rings stretch out hundreds of thousands of kilometers from the planet, forming an enormous disk that dwarfs Saturn itself. Despite their incredible width, the rings are surprisingly thin, often only about 10 to 100 meters thick in many places. This contrast between their vast expanse and their delicate thickness adds to the wonder of Saturn's rings. It's hard to imagine such a massive structure being so thin, yet so prominent in the night sky. Scientists have long wondered how Saturn's rings came to be. One leading theory suggests that the rings formed when a moon or comet ventured too close to Saturn. The planet's powerful gravity tore the object apart, scattering its remains into orbit. This process is known as tidal disruption and is closely related to the Roche limit, a boundary where Saturn's gravity overcomes an object's own strength. Over time, these fragments spread out and formed the rings we see today, creating a dynamic and ever-changing system. Tidal disruption is a fascinating concept in planetary science. When an object such as a moon or comet gets too close to Saturn, the planet's gravity pulls it apart. The Roche limit is the critical distance where this happens. The debris from the destroyed object doesn't fall into Saturn but instead spreads out, forming the rings. This process explains why Saturn's rings are made of so many small particles, rather than a single large structure. It's a dramatic event that shapes the planet's appearance. Particles in Saturn's rings don't simply float aimlessly. They are constantly orbiting the planet, held in place by a delicate balance between Saturn's gravity and their own forward motion. This is similar to how satellites orbit Earth. The gravitational pull keeps the particles from drifting away, while their speed prevents them from falling into Saturn. This dynamic balance creates the stunning ring system we see, with billions of particles moving in harmony around the planet. You might wonder why Saturn's rings don't simply collapse into the planet. The answer lies in the balance between gravity and the forward motion of the ring particles. As these particles move around Saturn, their speed keeps them in orbit, preventing them from falling inward. This balance is a fundamental principle in orbital mechanics and is crucial for maintaining the structure of Saturn's rings. It's a beautiful example of nature's equilibrium at work. Saturn's rings aren't continuous. If you look closely, you'll notice dark gaps within the rings, such as the famous Cassini division. These gaps are created by the gravitational influence of Saturn's moons, which clear paths in the rings as they orbit the planet. The moon's gravity pushes ring particles away from certain regions, resulting in these striking divisions. The gaps add complexity to the ring system and provide clues about the interactions between Saturn and its moon. Cassini division is one of the most prominent gaps in Saturn's rings. Named after the astronomer Giovanni Cassini, this division separates the A and B rings. It's caused by the gravitational pull of Saturn's moon Mimas, which creates a resonance that clears particles from this region. The Cassini division is a striking feature, easily visible through telescopes, and serves as a reminder of the intricate relationship between Saturn's rings and its moon. Saturn's moons play a crucial role in shaping the rings. Their gravitational forces create gaps and divisions and sometimes even shepherd ring particles into narrow bands. These moons act as cosmic sculptors, constantly influencing the structure and appearance of the rings. The interplay between Saturn's moons and its rings is a dynamic process, leading to the ever-changing patterns we observe from Earth. Saturn's rings permanent? Surprisingly, scientists believe they may be relatively young. Evidence suggests that the rings could be only a few 100 million years old, much younger than Saturn itself. Over time, the particles in the rings gradually fall into the planet, meaning the rings might slowly disappear. This discovery adds a sense of urgency to our study of Saturn's rings, as they may not last forever. Saturn's rings are not static. Over millions of years, the particles that make up the rings slowly drift inward and eventually fall into Saturn. This gradual process means that the rings are constantly changing, evolving as time passes. Scientists study these changes to learn more about the history and future of Saturn's ring system, revealing the dynamic nature of this cosmic phenomenon. Saturn isn't the only planet with rings. Jupiter, Uranus, and Neptune also have ring systems, but they are much smaller and less visible. Saturn's rings stand out because of their size and brightness, making them the most spectacular in the solar system. The large amount of reflective ice in Saturn's rings gives them their distinctive shine, unlike the darker, dustier rings of other planets. Brightness of Saturn's rings is due to the abundance of reflective ice particles. These icy fragments bounce sunlight back into space, making the rings shine brilliantly. This feature sets Saturn's rings apart from those of other planets, which are often darker and less noticeable. The dazzling appearance of Saturn's rings is a testament to their unique composition and structure. Saturn's rings are made up of several distinct bands, each with its own characteristics. The main rings are labeled A, B, and C, with smaller rings and divisions in between. Each band contains particles of different sizes and compositions, creating a layered and complex structure. The arrangement of these bands is influenced by Saturn's moons and the planet's gravity, resulting in a constantly shifting pattern. Particles in Saturn's rings vary greatly in size. Some are as small as grains of sand while others are as large as mountains. This wide range of sizes contributes to the ring's unique appearance and behavior. The larger chunks can cast shadows and create waves in the ring structure while the smaller particles fill in the gaps, making the rings appear solid from a distance. Most of the particles in Saturn's rings are made of water ice, which gives the rings their bright reflective quality. Some particles also contain rock and dust, adding variety to the ring system. The combination of ice, rock, and dust creates a beautiful mosaic of materials that orbit Saturn, each contributing to the ring's overall appearance. Despite their vast width, Saturn's rings are incredibly thin. In many places, the rings are only about 10 to 100 meters thick. This thinness is surprising given the ring's massive size, and it's one of the reasons why Saturn's rings are so visually striking. The delicate structure of the rings makes them appear almost ethereal, floating gently around the planet. Saturn's rings stretch out to hundreds of thousands of kilometers from the planet. This immense width makes the rings one of the largest structures in the solar system. The sheer scale of the rings is awe-inspiring, and it's a key reason why Saturn is so easily recognized in the night sky. The rings' vast reach is a testament to the planet's powerful gravitational influence. Saturn's rings are the most visible in the solar system. Their brightness and size make them easy to spot with telescopes and even small backyard instruments. The reflective ice particles enhance their visibility, allowing us to observe the rings from Earth. This visibility has made Saturn a favorite target for astronomers and space enthusiasts alike. Particles in Saturn's rings are constantly moving, creating a dynamic and ever-changing system. Collisions between particles can cause waves and ripples, altering the structure of the rings. This movement is influenced by Saturn's gravity, the planet's moons, and the interactions between ring particles. The result is a lively and complex ring system that is always evolving. Interactions between Saturn's moons and ring particles are key to the ring's structure. Some moons act as shepherds, keeping ring particles in narrow bands while others create gaps and divisions. These interactions are a constant process, shaping the rings and adding to their complexity. The relationship between Saturn's rings and its moons is a fascinating area of study for scientists. Saturn's rings are not permanent. Over millions of years, the particles that make up the rings gradually fall into Saturn, causing the rings to slowly disappear. Scientists estimate that the rings may only last a few 100 million years more. This means that the stunning ring system we see today is a temporary feature, adding urgency to our exploration and study. The timeline of Saturn's ring formation is still debated by scientists. Some believe the rings formed relatively recently, while others think they could be much older. Studying the composition and movement of ring particles helps researchers estimate their age and understand the history of Saturn's ring system. The ongoing research continues to reveal new insights into this cosmic mystery. Scientists use a variety of methods to study Saturn's rings, including telescopes, spacecraft, and computer simulations. The Cassini spacecraft provided detailed images and data, revealing the complexity and beauty of the rings. Ongoing research continues to uncover new mysteries, helping us understand the origins and fate of Saturn's ring system. Cassini spacecraft was instrumental in studying Saturn's rings. It orbited Saturn for over a decade, sending back stunning images and valuable data. Cassini's observations revealed the intricate structure of the rings, the influence of Saturn's moons, and the dynamic nature of the ring system. The mission greatly expanded our understanding of Saturn and its rings. Despite decades of study, Saturn's rings remain full of mysteries. Scientists are still unsure about their exact age, how they formed, and what their future holds. The rings' dynamic nature and complex interactions with Saturn's moons make them a fascinating subject for ongoing research. Each new discovery brings us closer to understanding this cosmic wonder. Saturn's ring system is constantly changing. Collisions between particles, gravitational influences from moons, and the gradual loss of material all contribute to the evolution of the rings. These changes are slow but steady, shaping the appearance and structure of the rings over time. Scientists monitor these changes to learn more about the processes at work. Movement of ring particles is influenced by Saturn's gravity, the planet's rotation, and interactions with moons. Some particles move in waves while others form clumps or bands. This movement creates the patterns and divisions seen in the rings, making them a dynamic and visually stunning feature of Saturn. Collisions between ring particles are common and play a major role in shaping the rings. These collisions can cause particles to break apart, stick together, or change direction. The constant movement and interaction between particles create waves and ripples, adding to the complexity of Saturn's ring system. Large ring particles can cast shadows on smaller particles, creating striking visual effects. These shadows are visible in images taken by spacecraft, revealing the three-dimensional structure of the rings. The interplay of light and shadow adds depth and beauty to Saturn's ring system. Waves in Saturn's rings are created by gravitational interactions with moons and collisions between particles. These waves can be seen as ripples or spiral patterns, adding to the ring's complexity. Scientists study these waves to learn more about the forces shaping the ring system and the influence of Saturn's moons. Some regions of Saturn's rings contain clumps of particles formed by gravitational interactions and collisions. These clumps can create temporary features such as bright spots or bands that change over time. The presence of clumps adds to the dynamic nature of the ring system, making it a constantly evolving structure. Saturn's rings are divided into bands, each with its own characteristics. These bands are created by the distribution of particles and the influence of Saturn's moons. The arrangement of bands gives the rings their layered appearance, making them one of the most visually complex features in the solar system. Divisions in Saturn's rings, such as the Cassini division, are created by gravitational resonances with moons. These divisions separate the main rings and add to the complexity of the ring system. Studying these divisions helps scientists understand the interactions between Saturn, its rings, and its moons. Some of Saturn's moons act as shepherds, keeping ring particles in narrow bands and preventing them from spreading out. These shepherd moons use their gravity to maintain the structure of the rings, creating sharp edges and distinct boundaries. The role of shepherd moons is crucial for the stability and appearance of Saturn's ring system. Resonance occurs when Saturn's moons and ring particles interact at specific frequencies, creating gaps and divisions in the rings. These resonances are responsible for features like the Cassini division and other ring structures. Understanding resonance helps scientists explain the patterns and complexity of Saturn's rings. The reflectivity of Saturn's ring particles is due to their icy composition. Sunlight bounces off the ice, making the rings shine brightly. This reflectivity is a key reason why Saturn's rings are so visible from Earth and distinguishes them from the rings of other planets, which are darker and less reflective. The distribution of particles in Saturn's rings is not uniform. Some regions are densely packed while others are more sparse. This variation creates the bands, gaps, and divisions seen in the rings. The distribution is influenced by Saturn's gravity, its moons, and the interactions between ring particles. The lifespan of ring particles is limited. Over time, collisions, gravitational influences, and the gradual loss of material cause particles to fall into Saturn. This means that the rings are constantly renewing and evolving, but they will eventually disappear as particles are lost. As old particles fall into Saturn, new particles can be added to the rings through collisions and the breakup of moons or comets. This renewal process keeps the rings dynamic and evolving, ensuring that Saturn's ring system remains a fascinating subject for study. Saturn's ring system is unique in the solar system. Its size, brightness, and complexity set it apart from the rings of other planets. The abundance of reflective ice, the influence of moons, and the dynamic nature of the rings make Saturn a standout among planetary ring systems. The beauty of Saturn's rings is undeniable. Their shimmering appearance, intricate patterns, and dynamic structure make them one of the most captivating features in the solar system. Observing Saturn's rings inspires awe and curiosity, reminding us of the wonders of the universe. Saturn's rings are not just beautiful, they are full of scientific mysteries. Questions about their origin, age, and future continue to drive research and exploration. The rings' dynamic nature and complex interactions make them a rich subject for study, offering endless opportunities for discovery. One day, Saturn might lose its rings, making what we see today even more special. The rings are a dynamic, ever-changing system, full of beauty and scientific intrigue. As we gaze at Saturn and its rings, we are reminded of the fleeting nature of cosmic wonders and the importance of exploring and understanding our universe.